All right, Algebra 1, moving on to 1.6B. Same kind of things that we were working with the other day with inequalities, and two different inequalities in the same problem. So here we have an OR problem. Green and blue, negative 6x is less than or equal to negative 18. I want to get x by itself. There's an imaginary multiplication sign right here, so let's divide by the whole number in front. So negative 6. Negatives cancel, 6 cancels, negative cancel, 18 divided by 6 is 3. Since we divided by a negative, we had to flip our sign from less than or equal to greater than or equal to. So there's half. Over here, reverse PEMDAS, so we got to add 24 to both sides. Then we're going to divide by 6, and x is greater than or equal to 7. So let's plot these on a number line. We always need 0. And then we need 3 and we need 7 right here. So here in the green, we have greater than or equal to 3. So since it's equal to, it's solid dot going to the right because it's greater than. And it's equal to, again, here at 7 and greater than, so it's going to the right. No, it can be one or the other. It doesn't have to be both. So it could be like if x is 4 greater than 3? Yep. Is 4 greater than 7? No, but it doesn't matter because it just has to be one or the other. So instead of drawing two lines or giving two answers, anything greater than 7 is also greater than 3. So let's be lazy. Let's just write x is greater than or equal to 3 because anything on this green line or anything on the blue line, if our answer is on the blue line, it's also on the green line because they line up, and any number greater than 3 is also greater than 7. That's kind of what it says down here. So we would say x is greater than or equal to 3. We'd only need one answer here because they're pointing the same direction. Here we have an AND problem in the blue and the orange, so let's divide by negative 4 to get x by itself. The negatives cancel, the 4's cancel, negatives cancel. 8 divided by 4 is 2. Since we divided by a negative, we had to flip our sign. So x is greater than 2. It's going to be an open circle going to the right. And we add 6 here, and x is less than 14. So it's going to be an open circle to the left. So since it's both, this blue line would be an open circle going to the right forever, and this orange line would be an open circle going to the left forever. But since it has to be on both lines, the only parts where both lines intersect is right here in between 2 and 14. So we would say x is in between 2 and 14. 2 is less than x is less than 14. Lastly, we have another OR problem. So we have red and blue. Let's distribute. So 6x minus 30 is less than 12. Add 30 to both sides, and then divide by 6. X is less than 7. So over here on our number line, we're going to say x is less than 7. We're going to minus 7 here, so x is greater than 3. So right here at x is greater than 3. Now it only has to be one or the other. I don't care which line it's on. So it could be on the red line or it could be on the blue line. So since it could be on the red line or the blue line, they're going in opposite directions, and there's no empty space on this graph. Every single possible number, so like negative infinity way out here or positive infinity way out here, would be on either the red or the blue line. So since those two lines cover the whole number line, we say our answer is all real numbers. Big thing is be really careful with your ands and ors. Ands have to be on the same, they have to be on both lines, and ors can be on like one or the other. So there's a little more flexibility with the ors. This is really confusing stuff, so if you need extra one-on-one time, email me. Let's set up a Zoom.